this video, I'm going to review how to solve quadratic equations and how to solve them using the quadratic formula. Then we're going to go over an example probably you might find on the ACT. Now when you have a quadratic equation, it's in the form of ax squared plus bx plus c equals 0. A, B, C, A and B are coefficients, and C is the constant value. Those values are plugged into the quadratic formula, and we can use this to solve for x. So the quadratic formula states that x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So this is one formula that you will need to memorize. This comes up pretty often in algebra, and you might see it on the ACT. Now in the quadratic formula, the value that's underneath the square root, b squared minus 4ac, is called a discriminant. Now when that is greater than 0, you'll have exactly two real roots. If that value is equal to 0, you have exactly one real root. And when that value is less than 0, you'll have exactly two complex roots. You'll get two complex roots because you'll be taking the square root of a negative number. Alright, so we have a quadratic here, quadratic equation, and we want to solve it. X squared plus 4x plus 4 equals 0. Now this is simple enough where you can just factor it. You can figure out two numbers that multiply to give you 4, and they also add up to 4. So that's simply just 2 and 2. So you just make your two parentheses. You have x plus 2 and x plus 2. And you set that equal to 0. Then you'll set each parenthesis equal to 0. So x plus 2 is equal to 0. You subtract 2 from both sides. And you get x equals negative 2. Over here, do the same thing. And you also get x is equal to negative 2. So your answer is negative 2. So x value of negative 2 will make this equation equal to 0. Now you can also solve this using the quadratic formula. So remember that's negative b plus or minus the square root of b squared minus 4ac divided by 2a. In this case, our a is equal to 1, our b is equal to 4, and our c is equal to 4. And remember, when there's nothing in front of the x squared, that's really just 1 x squared. Even in front of the x, if it was just x, it would be 1 x squared. So here our a is 1, b is 4, and c is 4. So we're going to plug those values in. So negative 4 plus or minus 4 squared minus 4 times 1 times 4 all divided by 2 times 1. Again, it's going to give us negative 4 plus or minus 4 squared is 16, and negative 4 times 1 times 4 is negative 16, and then 2 times 1 is just 2. So I'll get negative 4 plus or minus, and then 16 minus 16 is just 0 divided by 2, or negative 4 plus or minus 0 over 2, which is really just negative 4 divided by 2, and negative 4 divided by 2 is negative 2. Okay, so this is the same answer we got doing it both ways. You can always solve using the quadratic formula. If it's hard to factor, figure out two numbers where you multiply to give you the c value, and they add up to the b value. If that's taking too long to figure that out, you just go ahead and just use the quadratic formula. Also, if we look here, the discriminant came out to be 0, which tells us that we'll only have one real root. In this case, it was just -2. Now this one says x squared minus 6x plus 8 equals 0. So again, I can factor this and solve it. So I need two numbers that multiply to give me 8 and add up to 6, -6. So if you look at 8, I'm going to have 1 times 8 and 2 times 4. Those are my only choices. Now the add up to -6, -2, plus a -4 give me -6, so those would work out. So this gives me my two sets of parentheses, x minus 2 and x minus 4. And again, just set those equal to 0. And solve. Add 2 to both sides here. So x equals 2. Add 4 to both sides here. And x equals 4. So we get two answers, x equals 4 and x equals 2. Now I want to show you how to do it using the quadratic formula. So our a is 1, b is -6, and c is 8. So we're going to have -6. So remember to have both negatives in there, negative part of the equation, and our b is -6, plus or minus -6 squared. That's 4 times 1 times 8 over 2 times 1. Alright, so -6. So two negatives give you a positive when you multiply. So +6 plus or minus -6 squared is -6 times -6 or 36. And -4 times 1 times 8 is -32. And the bottom 2 times 1 is just 2. So that reduces down to 6 plus or minus the square root of 36 minus 32 is just 4. And then divide by 2. Now the square root of 4 is just 2. 2 times 2 gives you the 4. So the square root of 4 is just 2. And then divide by 2. Now I can reduce this. Each of them are divisible by 2. So this divided by 2 gives you 3. This divided by 2 gives you 1. This divided by 2 gives you 1. So you end up with 3 plus or minus 1. Now you split it up, you get 3 plus 1, which is 4, and 3 minus 1, which is 2. So x equals 2 and 4, just like we got over here. And if we look at our discriminant, we got 4 for our discriminant. So that's greater than 0, so we have two real roots. So we look at this one, we have 3x squared plus 13x minus 10 equals 0. So in this case, I need to multiply the a times the c. 3 times -10 gives you -30. Alright, so I need two numbers that multiply to give you -30 and add up to the 13. Okay, so I'm going to look at 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Those just multiply to give you 30. Now it has to be -30 and add up to +13. So we're going to do -2 and +15. Those two multiplied together give you -30 and add up to +13. So now I'm going to rewrite my equation with those two values, -2x plus 15x minus 10 equals 0. So I just replaced the 13x with -2x plus 15x. So they both equal the same, so I didn't really change the problem at all. Now what I'm going to do is I'm going to group the first two terms together and the second pair together. And they're going to factor. So the greatest common factor between 3x squared and 2x will be x. Leaves me with 3x minus 2. Greatest factor between 15x and 10 is going to be 5. So factor out of 5. It's going to be 3x minus 2 inside. Then from there, I'm going to factor out the 3x minus 2. That's going to leave me x plus 5. Okay. So a factor is going to be 3x minus 2 times x plus 5. Again, we set that equal to 0. Set each of these equal to 0. And then solve for x. I'm going to add 2 on both sides. 3x equals 2. Divide both sides by 3. So x equals 2/3. Subtract 5 from both sides. And x equals negative 5. So we get x equals negative 5 and 2/3. So let's see how it looks using the quadratic formula. So again, our a is 3, b is 13, and c is negative 10. That gives us negative 13 plus or minus square root of 13 squared minus 4 times 3 times negative 10, all divided by 2 times 3. And that gives us negative 13 plus or minus square root 13 squared is 169. And negative 4 times 3 times negative 10 comes out to be positive 120. And then 2 times 3 is 6. So that reduces down to negative 13 plus or minus square root 169 plus 120 is 289. Okay, divided by 6. And negative 13 plus or minus. Now we're going to evaluate the square root of 289. That's going to be 17 divided by 6. So now we got two things here, negative 13 plus 17 divided by 6, and negative 13 minus 17 divided by 6. Negative 13 plus 17 is 4. So 4 divided by 6, which reduces down to 2/3. And negative 13 minus 17 is negative 30 divided by 6, which will give you negative 5. So we get the same answers, x equals 2/3 and negative 5. Alright, so now let's take a look at an example ACT problem. Now this one says, what are the solutions to x squared minus 2x plus 26 equals 0? If I look at 26, it would be 1 times 26 or 2 times 13. Now none of those can add up to our b term, negative 2, so I can't factor to solve this. So when you can't factor, you're forced to use the quadratic formula. Now if we look at our discriminant, the b squared minus 4ac, we're going to have negative 2 squared minus 4 times 1 times 26. Negative 2 squared is going to give us 4. And then 4 times 1 times 26 is 104. That's going to end up giving us negative 100. And remember, when we have a negative number, a value less than 0, we're going to have two complex roots. Alright, so we use our quadratic formula. So negative b, so negative negative 2 plus or minus square root of b squared, so negative 2 squared minus 4 times a, which is 1, and c is 26. So remember our a, b, and c, and then divided by 2 times 1. So negative 2 gives us a positive 2 plus or minus. Negative 2 squared is 4. And we had over here, remember, it was 104. And then divided by 2. That gives us 2 plus or minus the square root of negative 100 over 2. Now the square root of 100 is 10. And remember, the square root of negative 1 is equal to I. So that's our complex root. So square root of negative 100, take the square root of 100, gives you 10, and the square root of the negative 1 to give you the I. So 2 plus or minus 10I over 2. Now I can reduce this because each of them are divisible by 2, so that becomes 1, that becomes 5, that becomes 1. So I'll get 1 plus or minus 5i. Okay, so we look at our answer choices. D, 1 plus or minus 5i is our answer. So this is a case where we are forced to use the quadratic formula, and since we are taking the square root of a negative number, we're going to have a complex answers. So 1 plus or minus 5i. And this one says, in the equation x squared plus mx plus n equals 0, m and n are integers. The only possible value for x is 3. What is the value of m? So in this case, we only have one answer. X is equal to 3. Now when that happens, remember we have our discriminant equal to 0. So when we have our sets of parentheses, there'll be the same value inside. So if x equals 3, it has to be x minus 3 in here, and it has to repeat, so we have only one answer. So remember, when we set these equal to 0, x minus 3 equals 0, we can add 3 to both sides. X is equal to 3. Okay, so when we have one answer, both parentheses have to equal the same thing. In this case, x minus 3. Now if I multiply this out, FOIL, x times x is x squared. X times negative 3 is negative 3x. And negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. They combine like terms. So x squared minus 6x plus 9. So the equation has to be this. So x squared minus 6x plus 9. And our m value will be the negative 6. So our answer is D. And this one says, which of the following best describes the roots of the equation 4x squared plus 12x plus 9 equals 0? Now, in the beginning of this video, we talked about the discriminant, which was the b squared minus 4ac. Okay, that's going to tell you what kind of roots you're going to have. So this one's going to be 12 squared minus 4 times 9. 12 squared is 144. And negative 4 times 9 equals 144. So we have 0. So if our discriminant is 0, we're going to have one real root. And it's going to be rational. Remember, irrational means you cannot write it as a ratio of two numbers, a over b. And if we were to actually, solve this, we'll end up with two sets of parentheses. And if there's only one answer, our value inside there will both be the same. So we really only have one root that's going to be double since there's two of them. So our answer here is one rational double root. If our value was greater than 1, you'll end up with either two rational roots or two irrational roots. So if we had a value like square root of 3, that'd be an irrational number. And if our discriminant was less than 0, we would have complex roots, two complex roots. So in this case, it came out to 0, and we had one rational double root.